video talks about balanced chemical equations. The objective of this video is to understand how to balance a chemical equation. The law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. That is, the total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. In other words, the number of atoms of each element remains the same before and after a chemical reaction. This is the reason why we need to balance a skeletal chemical equation. Consider the word equation. Zinc plus sulfuric acid gives rise to zinc sulfate plus hydrogen. Now this word reaction may be represented using the chemical equation Zn plus H2SO4 gives rise to ZnSO4 plus H2. Let's examine the number of atoms of different elements on both sides of the arrow. For the element zinc, the number of atoms in the reactants is 1 and the number of atoms in the products is 1. For the element hydrogen, the number of atoms in the reactants is 2, the number of atoms in the products is also 2. For the element sulfur, the number of atoms in the reactants is 1 and that of the products is also 1. Similarly, in case of oxygen, the number of atoms in reactants is 4 and that in the products is also 4. As the number of atoms of each element is the same on both sides of the arrow, this equation can be termed as a balanced chemical equation. Let us consider another equation and try to balance it. Fe plus H2O gives rise to Fe3O4 plus H2. Step 1. To balance a chemical equation, first draw boxes around each formula. Do not change anything inside the boxes while balancing the equation. Step 2. List the number of atoms of different elements present in the unbalanced equation. In this case, for the element ferrum, which is iron, the number of atoms in the reactants is 1 and that in the products is 3. For hydrogen, the number of atoms in the reactants is 2 and that in the products is also 2. And for the element oxygen, the number of atoms in reactants is 1 whereas that in the products is 4. Step 3. It is often convenient to start balancing with the compound that contains the maximum number of atoms. It may be a reactant or a product. In that compound, select the element which has the maximum number of atoms. Using these criteria, we select Fe3O4 and the element oxygen in it. Here, there are 4 oxygen atoms on the right hand side and only 1 on the left hand side. Therefore, in order to balance the oxygen atoms, we multiply the reactants with 4 so that the number of oxygen atoms in the reactants is equal to the number of oxygen atoms in the product. To equalize the number of atoms, it must be remembered that we cannot alter the formulae of the compounds or elements involved in the reactions. For example, to balance oxygen atoms, we can put coefficient 4 as 4H2O and not as H2O4 or H2O taken 4 times. Now, the partly balanced equation becomes Fe plus 4H2O gives rise to Fe3O4 plus H2. Step 4. Iron and hydrogen are still not balanced. Pick any one of these elements to proceed further. Let us balance hydrogen atoms in the partly balanced equation. To equalize the number of hydrogen atoms, make the number of molecules of hydrogen as 4 on the right hand side. In order to balance the number of atoms of hydrogen on the right hand side, we multiply the atom H2 with 4. Hence the equation can be rewritten as Fe plus 4H2O gives rise to Fe3O4 plus 4H2. Now step 5, examine this equation and pick the third element which is not balanced. In this case, we find that only one element is left to be balanced, which is iron. On the right hand side, we find 3 atoms of iron and therefore, to equalize iron, we take 3 atoms of iron on the left hand side. And hence, the equation changes to 3Fe plus 4H2O gives rise to Fe3O4 plus 4H2. Step 6. Finally, to check the correctness of the balanced equation, we count atoms of each element on both sides of the equation. The number of atoms of the elements on both sides of this equation are equal, and hence this equation is now balanced. This method of balancing chemical equations is called a hit and trial method, as we take trials to balance the equation by using the smallest whole number coefficient. Step 7 would be writing symbols of the physical states. Now carefully examine the balanced equation. There is no information which has been given in this equation which talks about the physical states of the reactants or the products. Hence, to make a chemical equation more informative, the physical states of the reactants and products are mentioned along with their chemical formulae. The gaseous, liquid, aqueous or solid states of reactants and products are presented by the notation G, L, AQ and S respectively. The word aqueous, which is AQ, is written if the reactant or product is present as solution in water. Hence, the balance equation can be rewritten as 3FeS plus 4H2OG gives rise to Fe3O4S plus 4H2G. Note that the symbol G is used with H2O to indicate that in this reaction water is used in the form of steam. Usually, physical states are not included in the chemical equation unless it is necessary to specify them. Sometimes, the reaction conditions such as temperature, pressure, catalyst and others for the reaction are indicated above or below the arrow in the equation, like in these cases. In this video, you have learnt to balance a chemical equation. First, draw boxes around each of the formulae. Then, list the number of atoms of different elements present in the unbalanced equation. Then, we typically start balancing the equation by considering the compound that has the maximum number of atoms and trying to equalize the atoms on the right hand side to that on the left hand side. After this, we consider those atoms which are still not balanced and try to equalize the number of atoms on the right hand side to that on the left hand side. We repeat the same step by picking other elements which are not balanced and trying to equalize the number of atoms on the right hand side to the left hand side. And this process is continued until all the number of atoms are balanced on both sides of the equation. And finally, to cross-check the correctness of the balanced equation, we count atoms of each element on both sides of the equation. And we complete the process by writing symbols of their respective physical states. Thank you.